The wave function is not real. The wave function is not a real object that occupies three-dimensional space. Think of any other wave that you know about. Could be a ray of light, could be a water wave. A water wave occupies many positions in three-dimensional space, right? It's got crests and troughs, and you can see them and you can feel them when the waves hit you and things like this. There would be no way to experimentally verify that the wave function is there, because once you go to measure it, famously, it's the whole measurement problem in quantum mechanics, there is no more wave function. It collapses to some real three-dimensional thing, whether that might be an electron getting bounced off of by a photon and some scattering event happening, or it hitting a detector or something like this. Now keep in mind, this isn't the exact same thing as saying that we can't know that the wave function is real. That's different. We can infer, you could make the case that the wave function is real because it's such a useful tool for predicting the results of experiment. But what I'm saying here is mathematically, the way that the wave function is defined in physics is not as a real object. So if it's not real, what is it? It's a kind of mathematical object. It's an abstract thing. It doesn't exist in three-dimensional space or 3+1 dimensional space-time, right? It exists in something called configuration space, or a Hilbert space. David Hilbert, along with Pascual Jordan, come up with a solution to this problem. David Hilbert comes up with an infinite dimensional vector space with an inner product that generalizes Euclidean space. That's all very technical, but he's a pioneer in the field of functional analysis. So people come along and say the wave function has to be real, it has to be a real object. There are a number of incredibly famous physicists who you've definitely heard of who considered the wave function to be a real physical object. One of them being Erwin Schrödinger, who came up with the wave function himself, the whole wave equation, right? Schrödinger's equation. He considered the wave function to be a real part of nature. Also Albert Einstein, in terms of mathematically the way the wave function is defined, it's defined in Hilbert space. It's in a configuration space. Right now, it's a mathematical tool because there's kind of no way to prove that it exists. This idea of the wave function being real or not, there's a lot of good people that talk about this stuff. Philosophy of physics people like Tim Maudlin and Jacob Arendes, they write books about this stuff. David Albert, not to be confused with David Hilbert, is also great at Columbia. So check out their books and interviews and whatnot, and let me know what you think about the wave function below. Thanks.